All right, let's dive right into this explainer. We're looking at some massive technological and operational shifts happening across the transportation industry right this second. Because, well, the Tesla Semi, it's officially entered high-volume production. And honestly, we are witnessing a complete paradigm shift here. We're finally moving away from just, talking about cool electric vehicle prototypes, and we're stepping firmly into the reality of mass-scale, AI-driven freight logistics. It is happening. Here's our roadmap for today. We're going to cover the 10-camera AI leap, the massive scale and hardware out of Giga Nevada, the totally new economics of freight, the Megacharger infrastructure, fleet compliance updates, and finally, crucial high-voltage safety protocols. Starting off with Section 1, the 10-camera AI leap. Smarter, not more. So think back to 2018. The original semi-prototype was absolutely bristling with 26 cameras just to cover the massive 72-foot length of the truck. So you might be wondering, why on earth did a 40-ton vehicle end up cutting 16 cameras, dropping down to just 10 on the final production model? Was it just them cutting costs? Well, actually, no, not at all. It all comes down to what they learned from nearly 8 million miles of real-world fleet testing. You see, it isn't about the sheer number of cameras, right? It's all about data consistency. By standardizing the truck with the exact same 10-camera Samsung AI4 architecture that's already used in millions of their passenger cars, Tesla essentially just dragged and dropped its existing neural network straight into the Semi. It's brilliant. They aren't rebuilding an AI from scratch for a truck. They're repurposing billions of miles of Model 3 and Model Y training data. Add in some repositioned cameras to eliminate those really deadly blind spots for smaller vehicles, and the strategy is crystal clear. Install the ultimate hardware today and just unlock the software via over-the-air updates tomorrow. Moving on to Section 2, high-volume gigascale, rolling right out of Nevada. As of April 2026, serial production officially kicked off at Giga Nevada. And get this, the manufacturing facility there is designed with an absolutely staggering planned capacity of 50,000 semi-trucks per year. Let that sink in. That means 50,000 heavy-duty vehicles rolling out annually, each of them continuously feeding high-quality AI data back into Tesla's network from literally some of the harshest commercial driving conditions on the planet. These production trucks are hitting the road with two officially confirmed, incredibly efficient battery sizes. You've got an 822 kilowatt-hour pack for the long-range 500-mile version and a 548 kilowatt-hour pack for the standard-range 325-mile routes. And both of these rely on Tesla's advanced 4680 NMCA cells. But here is the real kicker. Because they shifted to a 48-volt architecture and completely optimized the design, the production model is actually a full 1,000 pounds lighter than the prototype. Less weight directly translates to using a smaller battery to achieve that exact same target range, which, as you can imagine, vastly improves the fleet economics. And man, the industry is responding with some massive confidence. Just take a look at this quote from Watt EV's CEO right after they placed a $100 million order for 370 trucks. He explicitly calls out that electrified freight offers better economics than diesel today. This is not some far-off, futuristic promise, right? It's a present-day reality for their balance sheets. Which brings us perfectly to Section 3, the new economics of freight, subscriptions, and savings. So when we actually sit down and compare maintenance, the electric Semi completely eliminates those costly diesel items. We're talking no 15,000-mile engine oil changes, absolutely no transmission to service, and zero complex exhaust systems that require DPF regeneration. Plus, because regenerative braking handles like 80% of the deceleration, the mechanical brake pads are lasting 2 to 3 times longer. This doesn't just slash overall maintenance costs by roughly 50%, it drastically reduces vehicle downtime, and that keeps the trucks out on the road actually earning revenue, instead of just sitting around in service bays. Now sure, the Tesla Semi has a much higher upfront cost. We're talking $350,000 when you include the charger installation, compared to maybe $165,000 for a brand new diesel truck. But the fuel savings, they flipped the math entirely. When you look at typical commercial energy rates of about 12 cents per kilowatt hour compared to $5.35 per gallon of diesel, the 5-year total cost of ownership strongly favors the EV. In fact, over a 10-year period, a single Tesla Semi can save a fleet over $400,000. Yeah, per truck. But let's be real, handing over $350,000 up front, that's a huge barrier for a lot of operators. So to make adoption way easier, partners are rolling out these Semi-as-a-service subscriptions. And this is a total game changer. It completely removes the upfront capital risk for fleets. Basically, you pay a single fixed monthly fee that covers the whole shebang: the truck, the charging infrastructure, and the energy costs. It lets logistics companies immediately tap into those sweet TCO savings without having to gamble all their capital. All right, Section 4, Megacharger Infrastructure Impact. Because a truck isn't much use if you can't charge it, right? Tesla recently added 64 brand new Megacharger locations across 15 states to their map. This is a massive, incredibly fast national expansion designed specifically to support heavy-duty electric trucking. And if you look at exactly where these are placed, they map perfectly onto the major freight corridors, like the I-5 running straight up the West Coast and the I-10 cutting right across the South. They're focusing heavily on those huge logistics hubs in California and Texas. And the technology here? It's kind of mind-blowing. These stations boast 1.2 megawatt charging speeds. That means a driver can pull in and recover 60% of their range, so roughly 300 miles, in exactly 30 minutes, which, not coincidentally, aligns perfectly with a driver's federally mandated rest break. Okay, moving right along to Section 5. Let's talk EV fleet compliance and inspections. Now, just because the truck is electric, it doesn't mean it's exempt from a single FMCSA rule. Pre-trip and post-trip inspections are absolutely still legally required. So to handle this new reality, the new March 2026 EDVR rule officially clarifies that electronic inspection reports are fully compliant. This rule is really pushing fleets to adopt digital platforms, like the HBI app, for example, to manage these inspections seamlessly. Because think about it, a driver bouncing between a diesel truck and an EV needs entirely different checklists to load up automatically on their device. Let's quickly walk through the new step-by-step daily digital inspection requirements for those EV-specific components that drivers have to check off before they even hit the road. First, they've got to verify the battery management system dashboard for any startup fault codes. Second, they need to visually inspect the battery enclosure for any physical dents or unusual fluid leaks. Third, during their routine brake checks, they have to independently verify that the regenerative braking is decelerating smoothly right alongside the mechanical air brakes. And finally, number 4, they must ensure the high-power charging port is totally free of debris and that the heavy megawatt cable is properly stowed away. And finally, Section 6, High-Voltage Safety Protocols. This one is absolutely crucial. Every driver, mechanic, and dispatcher needs to understand the universal color coding for EVs. Basically, anything colored orange carries anywhere from 400 to 800 volts of direct current power. Guys, that is a fatal electrocution risk. Drivers must visually inspect these orange cables daily for chafing or damage, but they must absolutely, under no circumstances, ever touch them. Any damage found is an immediate out-of-service violation, and repairs, those can only be handled by specialized EV technicians wearing insulated Class 0 rubber gloves. Furthermore, fleet managers have to train their staff on thermal runaway. That's an uncontrollable battery heating event. If a battery enclosure is ever compromised, here is the exact step-by-step emergency response protocol. 1. Identify the warning signs. We're talking sizzling or popping sounds, smoke, or a really strong chemical odor. 2. Evacuate the vehicle immediately. 3. Establish a strict 50-foot safety perimeter. 4. When calling the fire department, dispatchers must explicitly specify that it is a lithium-ion event. And 5. Unlike some chemical fires where you'd never use it, copious amounts of water is actually the correct suppression agent to cool the battery pack down. So, we've looked at the massive AI integration, the mind-boggling gigascale production, the incredibly compelling TCO economics, and all those new regulatory and safety protocols. Look, the era of the electric Class 8 truck, it's no longer just some pilot project being tested behind closed doors. It is literally rolling out onto the interstate right now as we speak. With the hardware scaled, the charging network mapped, and the compliance rules set, the only real question left is your fleet prepared for the inevitable electric shift? Thanks for joining me on this explainer. Keep learning, and I'll see you on the next one.